Okay, now the next thing that we want to be able to do with the information that we just learned on how to find all of the zeros is sketch a general sketch. You would think you could just put some of these in your calculator and we would just see what it is, which is true, but sometimes they're so far off the little screen of the calculator that we got to have an idea as a human first so that we can find it. So it's important to know what these look like even before we go to the graphing calculator. So that's what they're talking about, general graphing and end behavior. Okay, here's what end behavior means. These things are going to wiggle. They're going to do something like this. Okay, this is the end, the one furthest to the right. What is it doing? So what is that tail doing? That tail is going up. We just want to see if that tail is going up or going down. So this end tail behavior is going up. And this is the front tail behavior. Okay, so most of the time we don't care too much about the front. We really only care about the end, but the front and the end are related. You see how these two are the same? They're both going up. So this particular graph, the tail behavior is the same. There's two things you say. They're the same. The tail behavior is the same, and it finishes up. Okay, so it finishes up and it's the same way. But it could be also like this. We could have something like this. Okay, see this tail behavior, when I say tail, it means this. What are the arrows doing? Those are considered the tails. These are the tails and these are the zeros. Okay, this tail behavior is opposite because one of them is going up and one of them is going down, and it finishes up. Okay, so we have that scenario. There's two more scenarios. We could have a scenario that looks like this. Okay, that tail behavior is the same because they're both going in the same direction, but it's finishing down. And then we could have something like this, where the tail behavior is different and it's finishing down. So they could be same up, opposite up, same down, or opposite down, different down. Okay, here's how you tell. All even kind of graphs are even tail behavior. Even tail behavior always finishes same. It's either both up or both down. So if it's even, it's going to be the same tail. It's either they're both going to go up. Now we don't care what's in the middle. There's going to be some wiggles in the middle. Depends on how many zeros there are. But if it's even, it's going to have the same tail behavior. If the highest power is odd, then it has different tail behavior. If it finishes up, then it started down, or if it finishes down, it started up. Okay, so odd tail behavior is always different. So, first of all, we know that this one's even. They're going to have same tail behavior. And then the other part about it is the leading term also decides how it finishes. If the leading term tells us what kind it is, same or different, and then the sign on that tells you how it ends. So positive means it finishes up. So whenever that's positive, it finishes up. So this is the same tail behavior, and it finishes up. So what the general sketch of that would look like is it's going to finish up. You start with how it finishes, and then it's going to do some stuff, and it will be the same. So it's the tail behavior that we care about. So these are the words. They finish the same. The tails are the same, and it finishes up, and it will look something like that. Okay, here's another even. That means it's going to be the same, but now this is going to go down. So the tails are the same, but they finish down. So the sketch of that, the same, it means it's going to finish down, do some wiggling, finish down. So you don't care what's in the middle right now. If the picture is how it finishes and starts. Okay, all of these are these first four are all even. That's silly. So this is even down. So it's same down. So it's that same picture. It's going to finish down and be the same. And this one is even, down. So they're going to finish the same and finish down. So it looks like that one again. Okay, so now we want to, number 5 actually wants us to start to sketch those. So when you sketch them, you get the tail behavior right, and you make it go through the zeros. Okay, so that means we have to find all 5 zeros here. There are going to be zeros that we have to deal with here. Okay, well, first of all, and make it equal to 0 and find it so I can factor out an x. Remember, we got to get it down to the quadratic formula. That leaves x to the 4th minus 3x squared plus 2. Here's one of them. It's going to cross at 0. Let's see. I'm going to put this, so this is, I can think of this as x to the 2nd minus 3x plus 2. I can think of it like that, so because this is a quadratic, this is a quadratic. If this one factors, that one factors. This one would just be x equals and x equals. So this one would be x squared equals the same number. So I'm going to use it looks like I could factor that to negative, how about I just factor it? That would be x minus 2 and x minus 1, like that. So that means this top one would factor into, I need it to go to the x to the 4th. So it would be x squared times x squared, and then 2 times 1. But if I make them both negative, negative 2 times negative 1 is still positive 2, and now they add up to negative 3, or negative 3. So it will factor like that. So it looks like x squared minus 2 equals 0. So x squared equals 2. So square rooting both sides. So x equals plus and minus the square root of 2 is or 2 more answers. So now I've got 3. And then this one is x squared minus 1 equals 0. So move the 1 over. So square rooting both sides. The other one is plus and minus 1. So there's all 5 of them. Now here's what I was going to do to my calculator just so you can see. I was going to run the quadratic formula on it, 1, negative 3, 2. The calculator gave me 2 and 1. See, that would have been the x squared. The x squared is 2 and the x squared is 1. See, the calculator thinks it's on an x squared, but if it's on an x to the 4th, it just doubles those. Okay, but either way we go, we get 1 plus or minus 1, plus or minus about 1.4, plus or minus 0. So there's our 5. So the way we graph that now, this is what we're looking for. 0 is where one of them goes. Okay, positive and negative 1 is another one. So I put dots where these zeros are, and that's 1.4. So I'll put a 2 out there. So about 1.4 and negative 1.4. There's all 5 of them. So first you get the zeros on there. Now when I come and look at this at the beginning, it was odd. That means it finishes different. Okay, and it was also positive, so it's going to finish up. You start with how it finishes. So this is the last 0 going to the right. So you start with how it finishes. It's going to finish up. And now you just weave yourself through these. So it's got to touch that one, so go through that one. Then turn, once you're on the other side of the x-axis, turn, so it touches that one. So we're making these mounds. And then turn, touches that one. And then turn, it touches that one. And then turn, it touches that one. And the tails should work out. If you touch all the zeros correctly, it should end up differently. So you start with up, and you weave it through all those, and we have different tail behavior. Now, you do not have to care how tall these are. That's going to be for our calculator later. We do want to know how tall that goes, but we're not going to do that by hand. We're going to do that with a machine. Okay, so this is what I'm looking for. Looking for the zeros and the general shape. Okay, let's take a look at this one. So I think I could probably, well, no, it's got a power to the 5th. So I think I'll just go ahead and look for these. So let's take a look for them. Negative 1, then a 0, then a positive 1. No, x to the 5th, x to the 4th, x to the 3rd is a 3, x to the 2nd is a 0, x to the 1st is a negative 3, and then the constant. Okay, I need last over first are the only ones I have to try. So the factors of 1 is just 1 and the factors of 1 out here is just 1, so it's going to be plus or minus 1. So it's either 1 or negative 1, but I need 5 of them. I have to find 3 of them like this, and then use the quadratic formula for the last 2. Okay, let's see what we have here. Drop the negative 1. 1 times negative 1 is negative 1, add. 1 times negative 1 is negative 1, add. 1 times 2 is 2, add. 1 times 2 is 2, add. 1 times negative 1 is negative 1, did not make it. Let me make sure, because it got so close here. It was off by a negative. Negative 1, add. Negative 1, add. That makes 2. 1 times 2 is 2. Okay, yep, looks like it didn't make it. So let's try negative 1. Okay, negative 1 times 1 now is positive 1. 0 plus positive 1 is 1. Negative 1 times 1, that's still going to be negative 1. That makes 2. Negative 1 times 2 now is negative 2. 0 plus negative 2 is negative 2. Negative 1 times negative 2 is 2. That adds to negative 1. Negative 1 times negative 1 is 1. Okay, negative 1 worked. There's one of them. Now there's 5 total, so I've got to find 3 of them, and I already know that positive 1 doesn't work. So I'm going to try negative 1 again. Okay, drop the negative 1. Negative 1 times negative 1 is 1. Add that is 2. Negative 1 times 2 is negative 2. Now that adds up to 0. Negative 1 times 0 is 0. Add that up to negative 2. Okay, negative 1 times negative 2 is positive 2. That one didn't work. Okay, so all we were able to do is find 1 this way. So let's go back to it. So this part now, right here, is the last piece that did work. So it was an x to the 5th, so this is an x to the 4th. So let's investigate what we have now left. This is an x to the 4th. So that's negative 1x to the 4th plus 1x to the 3rd plus 2x to the 2nd minus 2x minus 1 equals 0. Okay, are we going to be able to factor that by grouping? I don't think so. It's got too many terms. Okay, so I was going to wait on this for just a little bit, because one of the things the rational root theorem cannot do is find square roots or imaginaries when they're this big. And since we've exhausted all of them, I was hoping it would find 3 of them. But it did not, obviously. Okay, so here's the next strategy. We can't do it by grouping. It doesn't look like we have much going on here, so we really do now need our calculator. Okay, so go to the y equals, and let's put this in. Let's put that whole thing in there and see what it looks like. Negative x to the 4th. Plus x to the 3rd plus 2x squared minus 2x minus 1. I'm going to zoom 6 that and see what that looks like. Okay, looks like there's 2 answers to it right there. Okay, let's find those 2 answers. I'm going to zoom in on those 2 just a little bit with the box. So there's one and there's one. Hopefully we remember how to use our calculator to find those. Second, calculate a 0. Let's go get that one. So that one was at negative 1.29. Okay, and this one over here is at negative 0.39. Okay, now we can't really put those into this because because we don't have that as what that would have been as a square root kind of a number. So that's probably something like I don't know, 1 plus or minus the square root of 3 or something like that. If we had it in that term, we could probably put it in and see what it is exactly and get the last two imaginary roots. But this is as far as we're gonna be able to go on this one, is find only the real ones. So I could find one by hand, and then we needed a calculator assist. So what this is going to end up looking like is, okay, there's a 0 at negative 1. There's one at negative 1.29, so really close to that one. And then there's one at negative 39 right there. And then the other two are imaginary. So it's going to look something like this. Okay, it's not going to look something like that because it's going to finish down. So let me plot that again. That is not what it's going to look like. It's going to finish down with those 3 zeros. So one of them is at negative 1, one of them was at negative 39, one of them was at negative here. And we have to start with how it's going to finish. It's going to finish down. And now I'm going to come through those. Now, those are enough. You don't have to care about the two imaginary ones because they wiggle, but right now we don't know where that wiggle is. It might be over here, it might be over here, so we don't really have to care. What we're concerned about is this little bump right here is above the x-axis, and this little bump right here is below the x-axis. And if we type that in our calculator, the original now, I'm going to put in the original. Negative x to the 5th plus 3x to the 3rd minus 3x minus 1, and see what that looks like. I should be expecting the wiggles right in here. Okay, so see where they are? So now this is what this is for, to be able to do it a little bit by hand, is you can't really tell that they're there. Okay, but we know they're there. So if we zoom around that, we know that it's below 0 right here and it's above 0 right here. If I zoom box that, so you might think, why didn't we just graph it in the first place? Well, because we can't really see that there's 3 zeros there. That's why you have to have something, a strategy to be able to do it by hand so that we know to zoom in there. And if we do zoom in there, see there it's coming down and there it's going back up. So there's the little negative part and there's the little positive part. Knowing that that little section is negative and that little section is positive is a big deal. Now, on mine, see I put the little extra wiggle up here for those imaginaries. Well, it looks like they were really down here, but that part doesn't matter. We don't have to worry about those right now. We're worried about where the real zeros are. Okay, let's take a look at number 7. This one's going to have 3. It's going to finish down. Let's see, 3, 2, 0. So it looks like I'm going to try to do the rational root theorem on this one. If I can find one, I'll be able to do the quadratic formula for the others. So negative 1x to the 3rd, 2x to the 2nd, 0x, and minus 3. Okay, last over first. The factors of 3 are 1 and 3. The factors of negative 1 are 1. So there's only 4 possibilities. Plus and minus 1 or plus and minus 3. So let's see if we get lucky right off the bat. 1 times negative 1 is negative 1, add. 1 times 1 is 1, add. So that didn't do it. Try negative. Negative 1 times negative 1 now is positive 1. 2 plus 1 is 3. Negative 1 times 3 is negative 3. Add is negative 3. Negative 1 times negative 3 is 3. Okay, good. That didn't take very long. One of them is negative 1. It was an x to the 3rd, so this is an x to the 2nd. And I got to the quadratic formula real quick on this one, so let's go ahead and type that in. -1, 3, and -3. Okay, so the other two are imaginary. So there's only one real root here. So x equals -1 is the only one that we really have to worry about. So when I graph that, it's crossing at -1. Okay, it's going down, so it's finishing down, and it's gonna go through that one. It's gonna make some kind of wiggle somewhere, but there's nowhere else to cross, so it's finishing down, and sure enough, the tails ended up opposite. That's what we're looking for. If we put this one in our calculator, -x to the third, so -x to the third plus 2x squared minus 3, and graph that. Should be crossing at -1 with some extra wiggle around there, and there it is. It's crossing at -1. So again, I put my wiggle on the wrong side, but that doesn't matter. Okay, this one's gonna look similar. It's gonna finish down and be odd. So it's gonna look something like this, only it's gonna cross either 3 times or 1 time. So let's see if we can find this one. -1, 2, 0, -4. Okay, so last over first here. 1, 2, and 4 are the factors of 4. Now, I actually don't think I'll try -1 or -1 because neither one of them worked over here, so that's probably not it. I think I'll start out maybe with 2. 2 times -1 is -2, that adds up to 0. 2 times 0 is 0, that adds up to 0. 2 times 0 is 0, that's not going to be it. How about -2? -2 times -1 is +2, that makes 4. -2 times 4, that makes -8, that makes -8, that's not going to be there either. Okay, how about 4? It doesn't look to me like 4 is going to work. Drop down -1, that's -4, that's -2, -4, that's 8, -8. That adds up to -8, that's not going to make it. What about -4? -4 times -1 is +4, that's 6. That makes -24, that got too big in a hurry. Okay, I guess I'll check 1 just to make sure. -1, 2, 0, -4, we'll try 1. 1 times -1 is -1, that adds up to 1. 1 times 1 is 1, 1, that's not 4. Negative, that's 3. -1 times 3 is -3. -3, that's not 4. Okay, so now we have a problem. Okay, so we weren't able to find any of them by hand, so now we're going to have to go to our calculator and try to find them just with the calculator. So it's probably going to look like this, and we'll just find the zeros. So you might say, oh, we could have just done this in the first place. You're right, we could have just done this in the first place. But now we don't have any clues where any of the wiggles are, so we'll just have to see what happens. Okay, so it doesn't look like we needed any clues on this one. It's not close at all. There's one real right there, and then the other two are not really close. There's no way that they're hidden. That one and that one are imaginary. So there's one of them, and 2, 3 are right there. So we don't really need a clue, so let's just go ask the calculator for the 0. Get to the left of this one. It looks like it's close to -1 anyway. Get to the right of that one. -1.13. So there's the real one, and we just saw what it looked like. It's crossing at -1.13 and doing something like that. So that's what I'm looking for. Okay, number 9, I don't even know why number 9's on there. It's just right in the quadratic formula. I would go right to that. 2, -16, and 30. 5 and 3. Okay, so x equals 5 and x equals 3. We know it's going to go up and it's even. Okay, well, we also know that's a parabola. 1, 2, 3, 4, 5. So the tail would finish up. It's got to go through this one and this one. And there's the parabola. Okay, 10, there's 4 of them. Let's see if we can't find them by hand first, and then if we need to go and get it off our calculator, we certainly will. 1, 1, -1, and 4. The last over first, it's going to be 1, 2, and 4 over 1. So it's either 1, 2, or 4. 1 times 1 is 1, adds to 2. 1 times 2 is 2, adds to 1, not that one. -1 times 1 is -1, adds to 0, that's 0, adds to -1, that's not going to do it. So okay, how about 2? 2 times 1 is 2, 1 plus 2 is 3, 2 times 3 is 6, that adds up to 5, not going to make it. -2. -2 times 1 is -2, adds to -1. -2 times -1 is 2, that adds to 1, -2 times 1 is not 4. Okay, 1, 1, -1, 4. Let's try 4. 1 times 4 is 4, adds to 5. Okay, that's getting to 20. That's way too big already. That's -1 times -4. That adds up to -3. -4 times -3 is 12. That adds up to 11. Okay, so we're not going to be able to find it by hand. I don't think we can factor out. We can't do it by grouping. Nothing's helping us here. Oh, you know what? I did that wrong anyway. I didn't put in enough things. Okay, so you say, well, just put it in your calculator. We need to practice doing it by hand for mistakes like this. 1, x to the third, x to the second, x, and then the 4. Okay, let's see if that made any kind of a difference. 1 times 1 is 1, adds to 2. 1 times 2 is 2, adds to 1. 1 times 1 is 1, adds to 1. Didn't help there. -1 times 1 is -1, makes that 0. Makes that 0. -1 times 0 is -1. -1 times -1 is 1, adds to 1. Okay, so that didn't help. Let's go to 2. We'll try +2 first. 2 times 1 is 2, adds to 3. 2 times 3 is 6, adds to -5. 2 times -5 is -10. Okay, that didn't work. -2. -2 times 1 is -2, adds to -1. -2 times -1 is 2, adds to 1. -2 times 1 is -2, adds to -2. -2 times -2 is 4. So we found one. Okay, it was a fourth. Now I'm going to get down to the third, so I'm going to try -2 again. -2 times 1 is -2. That adds up to -3. -2 times -3 is 6. That goes to 7. That's not going to make it. Now, one of the things that we don't have to do is that the things that you've already tried will also not work. So we've already tried 1, plus and minus 1, and now we've tried plus and minus 2. So the only possible thing left could be a 4. So drop 4 times 1 is 4. That makes +3. 4 times 3 is 12, and I think we're way too big. -4. -4 times 1 is -4. -1 and 4 is -5. That makes 20, and I think we're way too big. So I think the only real one that we've got so far is the -2. Okay, so right here's where we were at the -2. That leaves, we started out as a fourth power. That means we've got x to the third minus x to the second plus x minus 2. Now, the more powers, the smaller the power you get, the easier it is for your calculator to deal with and show you something. So I'm going to put that now in the calculator. So we've got x to the third minus x squared plus x minus 2. Okay, so see, there's nothing going to be hidden. This little wiggle is not right up on the line. I don't have to zoom in. It's that one right there. So it's second, calculate the 0. I'll come to the left. Okay, I'm already to the left. Go to the right. I'm already to the right. So that one is at 1.35. So from up here we had x equals 2. From up here, we had x equals 2, and now from my calculator, I have 1.35, and the other ones are imaginary. Now that makes sense, because there's two reals, and then the imaginaries have to come in pairs. So when I sketch the quick graph of this, I know it's going to have positive tail behavior. One of them's going to cross at 2, one's going to cross at 135, positive tail behavior. After I get done going through these, it should also look even. So I'm going to come through this one and come through that one, and sure enough, it looks even. Now there's probably some wiggle somewhere. I'm going to put this in the calculator just to see. See what we could have maybe done at the very beginning is go x to the 4th plus x to the 3rd minus x to the 2nd plus 4. Let's just see what it looks like and how close we got. Whoa, that's not what we have. We have it crossing at 2 and 1. X to the 4th plus x to the 3rd minus x to the 2nd plus 4. That does not look like what we have. The calculator thinks they're all imaginary. How did we get this 2 right here to work? Okay, I better go back and make sure. Did this actually not work? So if you saw the mistake that I had made, you might be yelling at me right now. Okay, 1, 1, negative 1, so 1 x to the 4th, 1 x to the 3rd, negative 1 x squared, 0 x, and 4. And I thought 2 worked. So drop down the 1. 2 times 1 is 2, that adds up to 3. 2 times 3 is 6, that adds up to 5. That 2 times 5 is 10. Okay, not 2. Did I think negative 2 worked? Negative 2 times 1 is negative 2, that adds up to negative 1. Negative 2 times negative 1 would be 2. Negative 1 times 2, that adds up to 1. Negative 2 times 1 is negative 2, that adds up to negative 2. Negative 2 times negative 2 is 4. Okay. Oops, I did all that off camera. I just did the negative 2. Negative 2 times 1, that adds up to negative 1. Multiplies 2, that adds up to 1. Multiplies negative 2, okay, negative 2 times 2 is 4. That is not 0. That one actually did not work, for crying out loud. So we were not able to find any of those. So we couldn't find any of them by hand. Then the only thing you can do is type it in your calculator and look and see. And now when I do that, you can see that there are no real roots. Okay, so when there are no real zeros, we just see it off our calculator, it means it's never gonna touch. It's gotta end positively, so it's gonna end up, but it cannot touch the x-axis, so it just did wiggling and stayed the same, had same tail behavior. This is what we're looking for, no real roots with that. So sometimes, so we have strategies to find some of them, and sometimes we need the calculator to help us out to find the imaginary ones.